Computer Fundamentals and Programming for Engineering Lab. The final requirement for the course by Engineer Emmanuel Longares. First semester, school year 2020-2021, De La Salle University, Dasmariñas. Traffic lights using Python by Messiah Job C. COLLAO, Denise and COLLAO, Dion Imperial. Hey guys! On this video, we're going to create our own traffic light using Raspberry Pi 4 and Python. The point of this video is to help other people who wants to learn this kind of project using Raspberry Pi. So let's start. Here are the materials we need. Raspberry Pi 4, micro USB Type-C power supply, HDMI cord, micro SD, LED lights, resistors, jumper wires, and breadboard. First in the list, Raspberry Pi 4. Raspberry Pi is a low-cost and credit card sized computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Scratch and Python. In this case, we have a Raspberry Pi 4 Model B. It is the latest product in the popular Raspberry Pi range of computers. Micro USB Type-C power supply. The power supply requirement differ by the Raspberry Pi model. All models all models requires a 5.1 voltage supply, but the current supply generally increases according to the model. HDMI cord. The Raspberry Pi has an HDMI port which you can connect directly to the monitor TV with an HDMI cable. Next in the list, micro SD. The micro SD card is the key part of the Raspberry Pi. It provides the initial storage for the operating system and files. In our project, 32 GB micro SD, and this is the vast majority of project. Sticking to a 32 GB or below is the best. LEDs. Since we are going to create a traffic light, we are going to use LEDs. Green for go, yellow for ready to stop, and red for stop. We have 3 pieces standard LED, which is the simplest and most used component in our toolkit. This handy acronym stands for light emitting diode. LED bulbs can be used in any application where you need to show something happening or notify the user that something is ready. Resistors. The resistors in the circuit will ensure that only the small current will flow and the Raspberry Pi will not be damaged. Resistors are a way of limiting the amount of electricity going through a circuit specifically. They limit the amount of current that is allowed to flow. We have 3 pieces of 300 ohm resistor for the LED, and resistor will determine the speed of the blinking. Next, the jumper wires. The jumper wires are typically used with breadboards and other prototyping tools in order to make it easy to change a circuit as needed. In our project, we have 4 pieces jumper wires with different colors: yellow, blue, green, and brown. These wires has female and male. The difference between each is in the endpoint of the wires. Male ends have pin protruding and can plug into things, while female ends do not and are used to plug into things. Lastly, the breadboard. The purpose of the breadboard is to make quick electrical connection between components like resistor, LEDs, capacitors, so that you can test your circuit before permanenting soldering it together. Breadboards have many small sockets on them, and some of the groups of sockets are electrically connected to each other. Procedure. The next part shows the process. First, we connected the mouse and the keyboard to one of the USB ports. Like a normal CPU, we still need the mouse, keyboard, and the monitor for basic input and output. The Type-C port near one of the corners is the power port. The Type-C adapter is connected to the power cable before plugging it into the port. Then, we take the 32 GB micro SD that has pre-installed new out-of-the-box system or NUBS. This is the Easy Operating System Installation Manager for Raspberry Pi. The micro SD port is underneath the microcontroller. It is not a spring system port. So we have to be carefully inserting the micro SD. We added the cooling fan in the PI for caution. Although the appropriate heatsink are already there, the cooling fan helps avoid the overheating. We connect the red female connector to the 5V pin and the black male connector to the GND, the ground pin inside it. To keep it from moving, we place the double-sided tape under the fan before placing it on the top of the processor. Our monitor and the Raspberry Pi is connected with an HDMI cord. The micro port end of the cable is the one connected to the Pi. We can now plug the Raspberry Pi to the source. It takes less than a minute to initiate to the end. Since we tried it beforehand, we have already set up the language, time zones, Wi-Fi connections, and password. The menu is at the upper left side of the screen, beside this internet browser, Chromium, Files button, and CMD terminal. We already downloaded and installed the Python idle by using the Chromium web browser. We use the idle Python because we are more familiar with it and its interface, even though the Tony Python idle is already available in the Pi. Before going to the code, we must first assemble the LED lights and connect it with the Pi.
Configuration of our breadboard is shown in this picture. If the board is facing you this way, the row with pink highlights are internally connected. In some breadboards, the connection extends to the other column of the same row. On the other hand, the holes of the selected column are internally connected, and this is the same for all columns in the middle board.
The breadboard provides temporary connection between some electronic elements. So, we connected the shorter leg of the LEDs to the horizontal connected holes. This way, all the short legs, which is the negative side, is connected to the single node. We place enough distance between the LEDs so as not to the overcrowd. We take one of the 300 ohms resistor and connected one leg in the same node of the positive leg of the LED. The other leg should take a different node anywhere in the vertically connected holes. Make sure it is not connected to any of the other elements. The LED regulates the current flow to the LED. This way, it would not damage the LED or the Pi. Each LED is now connected to a 300 ohm resistor. Now, going back to the Pi, we temporarily disconnected the heating fans from the Pi so that it could be easier to plug to the jumper wires onto the GPIO pins. The pins have different uses and each of the specific names and numbers assigned to it. A few of it has output voltage, some of the pins are GND connections. Since we have already used the 5 voltage pins and the GND pins for the fan, we picked an area in the middle part of the space. We take the female end of the connector instead of the male. The male end cannot connect it to the pin. We connected the brown jumper to the 10th hole from the top. This is the ground node. Without the red jumper, we use the blue one and place it on the GPIO 10 directly across the GND jumper. The yellow goes below the blue jumper which is the GPIO 9. Next to it is the GPIO 11 where the green jumper is placed. After that, connect the ground pin to the node where the negative leg of the LEDs are connected. Remember, only half of the row is connected. The male end of the jumper wires in the GPIO pins can now be connected to the LED resistor series. We use color code to identify the connection easier. The blue jumper is connected to the end of the red LED resistor series, yellow jumper for yellow LED, and the green for green. We can now plug the pi and the source in the code in Python. So you can see the video. Yellow for yellow and green for green. We use this to easier identify the color to color. We can now plug the pi to the source and the code in the Python. The first line in the code enables us to use LED as its name instead of GPIO. The next line on the other hand activates the sleep mode in time so that we can indicate how long the previous line is run before continuing to the next line. Although we can call the GPIO as LED, the numbers assigned do not change. We place that into a variable for easier access. Initially, we have set a counter so that the code will not turn into an infinite loop. The line where subtract 1 to t was not in the last line of the first while block. After that, we set the LEDs as off at the start so that we know when it actually starts the loop. It was supposed to have 6 loops, that is why t is less than equal 5. The sequence is the green light will turn on for the first 10 seconds, then turn off. The yellow will only light up for 5 seconds and then turn off. And the red light will light up for 10 seconds before turning off. Since the t minus equals 1 is missing, the else statement won't be executed. The GPIO cleanup is supposed to reset the program so that the lights will be off the start. Now the execution. To save time, we have tried another sequence with faster switches before the LEDs. Now, this is the end of the presentation for our final project in CPET 001 LA, taught by Engineer Emmanuel Longares at the De La Salle University. From Member 1, Member 2, Member 3, thank you for watching.